Welcome back to Henry Harrison's Entrepreneurs Business and Finance podcast, featuring Hiten Sonpal, CEO of Rise Robotics. Don't forget to like and subscribe so you don't miss an episode. Enjoy the show.
Welcome to Entrepreneurs Business and Finance, the Henry Harrison podcast. We are welcoming today on our show a very interesting CEO and business person, Hiten Sonpal, and he is the CEO of a technology company, and I'm going to let him speak about it since it's his company. Hello.
Hi, Henry. Thank you for having me on the podcast. I'm CEO of Rise Robotics, and we are a MIT-affiliated startup based in Somerville, Massachusetts. And our core technology is replacing hydraulics. We built fluid-free linear actuators for heavy machines. And not only do we enable the electrification of these machines, but we also enable teleoperation and autonomy.
Step back a minute. MIT affiliated. What does that mean for those that don't know?
Yeah, the founding team is largely from MIT. They started the company in 2011. They had a vision to build an the Iron Man suit without the jetpack. And as they started in that process, they had left MIT when they started this. So I say affiliated because we're not a spin out per se, but we still have strong connections with MIT. And they had this vision to build this exosuit, and they started designing the exosuit and started looking for how they were going to move the various actuators in the exosuit. And the goal was to build something that, you could lift a car with and, topple it, right? Something that strong could be used for military applications, inside warehouses, and then scaled on versions could be used to help the elderly move around with assistance. And as the team was looking at the technologies that were out there, they realized that really there was nothing out there that they could use for the system. They looked at hydraulic systems, but those were heavy, slow, leaked, inefficient. And so they had to invent something new. And we invented this technology called Beltrolic, which I'll get into in a second. And then once they invented Beltrolic, they realized that it was better to tackle the existing hydraulics market, which was huge at $750 billion a year, versus try to invent an exosuit market where they could put the technology inside it.
Talk about hydraulics, the uses are for hydraulics.
Yeah, hydraulics is used in all kinds of heavy machinery, especially in any heavy machine that you need to pull or push or lift or lower, right? So in those systems, there really haven't been any innovations in electrical actuators. And so companies, even the ones that try to electrify their machines, ultimately end up using electricity to run a pump, which pushes liquid around. And the liquid eventually then moves the piston, and the piston then finally does the real work that needs to be done, whether it's lifting, pulling, pushing, or lowering.
Got it. Yep. And some of this I do know, but I'd rather you be the one to say it. And not everybody does know. Well, then looking behind you there is a part of your facility. What in the world do you do down there with all that equipment?
This is our lab, and since we're at the very beginnings of scaling the company, we do our development and manufacturing here. We have a fair number of products that you can see. Let me see if I can get to one of our first products here. That product back there is a collapsible lift crane that we built. It's the one with the hook on it. I want to make sure you can see the hook. That was built for the Air Force. They had a specific mission where they wanted to lift 150 pounds into a plane. And the existing device they were going to use weighed 1,800 pounds. And we built them something that did the same thing, but weighs 300 pounds. So it's 1,200 pounds lighter, which they promptly turned into fuel, which gave them more range for the mission. So it was really exciting. And they bought $1.5 million worth of that product under commercial terms. And that was really our first product. And that happened before I joined the company. It was one of the things that gave me confidence that what I needed to do in this company was not really science, but to actually commercialize technology that had already been productized.
So they developed that crane, if I'm calling it the right thing. And then who built the crane?
The crane ourselves, because the quantities were very small. And when we kind of looked at our initial production contract, it was small enough that we felt like we could tackle it in-house. If the contract size had been much larger or much longer, then we would have engaged a contract manufacturer to help us with the process. But it didn't make sense at the volumes and the timing that they were looking for.
And when you're talking about commercialization, you're taking concepts, potentially, the original one was a concept, but you're taking concepts or technologies and taking them to the stage where someone wants to buy them and use them. And then you'll work with, if you can make it yourself, you'll make it, or you'll work with a big contract manufacturer if it's something beyond the scope of the size that you want to be at the moment. Is that
That's
correct?
right. And that is correct. And when you're thinking about kind of the early stages of commercializing a business, you're not only thinking about how to scale production, because that's one piece of it, but you also have to think about scaling application engineering. Because when we talk about hydraulics, and I mentioned it's a big market, 150 billion out of the 750 billion is in industrial systems, and then 600 billion is in mobile hydraulics. Think off-highway heavy machines, bulldozers, rather than talking about machines, maybe it's easier to talk about sectors. So think about construction, agriculture, marine, mining, forestry. Like these are the big sectors where you end up using these systems. And so for each of those verticals, you need to develop a little bit of an application engineering team that understands the specific requirements of the customer. For example, mining is often running 24/7. It's very repeatable. And when you think about construction, the machine aren't being operated as often, but they have to deal with, call it operator abuse. They have to deal with a wide range of environments and uses of the equipment that you didn't think about. Sometimes you build something that's used to dig, and since it happens to be the only tool off site, it'll be used to push things and drag things, right? And so you have to just understand what those use cases are. So taking a step back, scaling a business isn't just about building the manufacturing team, but it's also scaling the application engineering group so we understand the end user's pain points. And it's about building the sales and marketing team so we can support them, and then distribution. All of that has to be thought through in terms of scaling. It is for a company at this scale, it's a very interesting problem, one that I have some expertise in, having spent a fair amount of time at iRobot.
Yeah, maybe that's a good lead in. Talk about how you developed the experience to become the CEO of this company. And then we can lead to what are the future goals of this company, because they brought you in, or you decided to come in a few years ago. And I'm sure there's reasons and plans that came along with that.
Yeah, I spent a large portion of my career at iRobot Corporation. They invented the Roomba, if you're familiar with that product. But they also had a military group, which I joined initially. And I joined the military group because I've been working with a consulting firm that had DARPA and iRobot as a client. It was a three organization team. And we were working on soldier portable robots. And 9/11 happened at the same time we were working on these systems. And we got the call from DARPA within 2 hours of this happening. And they said, "Where are those robots?" And we had to take the prototypes that weren't really finished, quickly get them into a state that they could be deployed in. And then the company that I was with was a small consulting firm, and the owner was a private pilot. So he was able to take our robots, get them on a plane, and he was one of 5 planes flying the day after 9/11, flying these robots to ground zero. And up until that point, I had been pretty much a geek, interested in just the tech and solving interesting engineering problems. But at that moment, there was like a shift inside me because I felt that I was making such a big difference, that my product, the product that I was working on, was going to be used to save lives. And so at that point, I decided that I wanted to find a way to work for iRobot because they were doing other interesting things in the defense space. And a couple of years later, I joined them, and then I worked in the military business, which ended up shipping 1,200 robots to Iraq and Afghanistan, primarily used for bomb disposal. And it was a wonderful time because everybody in that organization, in the military business, was very mission driven. We knew we were saving lives, and that was very exciting. And then iRobot spun off its military business, and I stayed in the consumer business. And there I ended up leading a number of product development teams, and we collectively shipped 9 million units, generated 2 billion in revenues across 20 products. And during that journey there, I just kept taking on more and more responsibility. Sometimes I had to take a step down in the organization so I could broaden my scope. But I did that because I had mentors in the organization that recommended that if I really wanted to grow, I just couldn't grow just straight up. I had to start broadening my base so I could take on more and more responsibility. And then COVID happened, and the project that I was working on was canceled. I was working on Roomba for your lawn, the next big thing at iRobot, which is a lawnmower, a robotic lawnmower. But we couldn't launch because of COVID. And so I looked around, and there really wasn't much more I could do at iRobot. So I left, tried to spin out that company into its own organization to see if I could complete the project. And just given the timing, I was not successful in doing that. But in that journey of trying to spin out that business, I learned how to talk to VCs. I understood what they were looking for. And then because of that experience, where I didn't really succeed, but I gained all this experience and learning, I was recruited by a startup based out of Dallas called Mobot. They hired me as their head of product and strategy, eventually promoted me to be their CEO. And then after that, I joined a company called Electric Sheep, where I was their president. They were based in the Bay Area, doing commercial robotic lawnmowers. And then I did some consulting briefly because they were not able to raise their next round. And then I met a friend who worked at Rise Robotics and told me what they were doing. So I joined them as a consultant, helping them commercialize their tech, which is what they were looking for. And at some point, they asked me to be their CEO. So that was the journey getting here. One of the things that really excited me about Rise is this lab that you see back here. Anyone that visits this lab realizes that the company has spent almost $0 on waste. It's all gone into R&D. There aren't a lot of creature comforts in our lab or facility. I mean, we do the minimum required to retain employees, and we meet all of the OSHA. We pass all of the OSHA audits and so on. But our focus is really on the R&D, and that got me really excited. And then I took a look at the company's patents, and because initially, when my friend was working or told me about the company, I didn't think that what they were doing was possible. I didn't think that there was a way to replace hydraulics with anything but screw type actuators. And I knew that those didn't scale up. But then after I looked at the patents, I was really excited and really wanted to find a way to work with these folks. And so one thing led to another, and now I'm CEO.
What's the future look like? Future plan for the company that you can share publicly?
Sure. We have three business areas. We have our defense business. As I mentioned, we had really good success shipping the collapsible crane to the Air Force. And they asked us to tackle their next big hydraulic problem. Just to take a step back, the existing crane that we were replacing was a hydraulic-based system. So once they saw us come up with a solution that didn't require hydraulics, they said, okay, our next big problem is these aerial lift trucks. They have these devices that are called MHU-83s. They're munitions handling units, and they're rated to lift 5,000 pounds, and they typically are used to attach munitions onto planes. And the latest munitions have gotten much heavier than these trucks can handle. And also this truck design is from the 80s. So it ends up leaking a lot of hydraulic fluid. These are diesel powered machines, so they're loud, they emit smoke, and sometimes the munitions are being loaded in hangars. And so our warfighters end up inhaling smoke, diesel smoke. They're subject to a lot of vibrations. There's a lot of noise, so they're wearing ear protection, but they are yelling over the machines, which reduces their efficacy. And just watching the operations of one of these systems, you realize that this tech is really outdated and needs to be replaced with something new. Oh, and I forgot to mention, it leaks hydraulic oil. And when we've gone to visit these sites and see the operators use these machines, one of the things they tell us right away, and we know this, that, okay, those hydraulic oil spills, they are like ice patches. Do not step on them. Otherwise, you're going to slip and fall and get injured. So because they're telling us this, we know that's happened to our warfighters that are just, even if they're doing exercises, right, they're subject to this equipment that's not really state of the art. And I think they deserve something better. We're excited about that mission, and we're modernizing these aerial lift trucks with something that's completely electric, that uses our core technology, that is hydraulic free, that is quiet, and then can be diesel or electric. To make it a hybrid system, you would just attach a diesel generator because the system on the inside is drive by wire and electric. And then you could choose when it would be noisy. You could choose when it would emit smoke. And if you needed to be in a quiet setting, you would just turn it off. So lots of flexibility in this next generation system. And the first thing we did for them is we built a prototype of the core arm, because lifting 7,000 pounds is a substantial challenge. And you're lifting it underneath the plane. So the truck has to be off to the side. And you have this 7-foot reach where you're trying to lift 7,000 pounds. That's a big challenge. And we ended up designing something that used that big cylinder there. That cylinder is attached to a forklift test stand. It's capable of lifting 22 tons. And so we put that into the system, and we built them a prototype arm that could lift 7,000 pounds, did a demo. They were really excited about that. The team then realized that we had built the world's strongest robotic arm. So we called a Guinness World Record team, and we got into the Guinness book for building the world's strongest robotic arm. And that helped us in a couple of ways. The first way it helped us is that for a lot of us, it was in our bucket lists to get into the Guinness book. So that was fantastic. But the second thing was that we really wanted to make it evident that what we were building was as strong as hydraulic systems, right? And we were replacing a 5,000 pound arm that was built out of hydraulics with a 7,000 pound arm that was completely all electric. So that was a huge accomplishment for us, and it's brought us a lot of inbound interest on the sales side. After we built that arm, we won a $3 million contract extension. This happened in January, and now we're building the full air lift truck, the full device. And that's going to go into pilots end of next year. And then we expect it to go into production afterwards. There are about 1,500 of these that have to get replaced. So it's a huge opportunity for us. So that's on the defense side of the business. Then we have a liftgate business. Let me show you here. I think you might be able to see we have a liftgate down there that we're testing. And what we built is the first hydraulic-free liftgate. Liftgates are challenging devices because they're trying to do a lot. Those liftgates, that particular liftgate lifts 5,500 pounds. And the common failure mode is, of course, the hydraulic system fails. But because the hydraulic systems are inefficient and they consume a lot of battery, another common failure mode is that it kills the battery either on the liftgate or worse on the truck. And then the truck is stranded or the liftgate is stranded open. And so then you have to send another truck out to, get it back into the shop. And that's a substantial cost. So both between reliability, downtime, and then certainly efficiency, because our systems can run much faster than hydraulic systems. We believe we have a compelling value proposition there. We're developing that liftgate in partnership with Anthony Liftgates, and currently we're in pilots with a very large fleet. So that's our liftgate business. And then on the cylinder side, we're building cylinders to sell directly to OEMs that want to build hydraulic-free machines. We selected our first 3 customers, and I say selected, not landed, because we have more inbound than we can handle, but we have to be very picky about the customers we pick because it's easy to partner with someone that's very large and very slow and consumes a lot of your time and money before they decide that they don't want to work with you, or they have a reorganization, or your key stakeholder leaves, right? So we want to work with, at this time, nimble organizations that have a specific pain point that they're trying to address. So the first customer we selected on the cylinder side is in the oil and gas sector. And their challenge is, so they're building natural gas pumps to capture natural gas that's escaping from oil wells, and they're pumping it up to sellable pressure. And their challenge is that their hydraulic pumps fail every 3 months. And it's a hydraulic system that gets fouled up. And so they have to go service it. These pumps are distributed across oil wells all over Western Texas. So the process of getting to them, servicing them, getting them back up is a substantial impact to revenue and also manpower. And so by using our cylinders, we expect that they'll be able to extend the service life to 9 months, which doesn't seem like a lot, but since they can't hire any more people to service their systems, we're going to triple their service revenues for the same team. So we really try to focus on those key pain points and those key areas where we can make a difference. And we're also piloting with them. So we're in this sort of very early stage of commercialization where we understand the segments we want to get into and are starting to build in small volumes, call it low rate initial production, which we're doing here, and then eventually intend to start getting to scale. That was a long answer to a short question.
I know that's a very, very interesting. And for those that don't know, a pilot is when you're actually testing something in a small number, or maybe even a unit of one. It can be many different things. But then after pilot, well, they go through steps. So idea to it's being used.
Yeah,
And
that's a
when
good
I
point.
say
So
used like the crane, or used like and it's very interesting, I think, saving lives, right? Using those robots to go
yeah,
disarm instead of people going in with those big suits that don't totally protect them. And
yeah. So back to kind of all the steps. Yes, certainly you have an idea, and then you want to, well, let me take another step back here. So generally, when you think about product development, you're trying to solve for the intersection of feasibility, desirability, and viability. Feasibility being, can you actually, from an engineering perspective, design a solution that works? Desirability is, okay, so you build something that's novel and it works, but does your customer really want it, right? And so that you've got to test for that. And then the last piece is viability. Okay, so you built something that's novel, you found a pain point and the customer is interested, but can you actually make it and sell it in a way that the business is viable and can make money, right? So we've done the feasibility part very well. We have a few handful of bugs that we find when working with customers on corner cases that they discover. The pilot is predominantly about desirability of the product. So our goal here with the pilots is this particular the customer that's building these natural gas pumps wants to make sure that our systems run for 90 days. as a key initial test. And if they run for like 90 days, then they want to deploy more of them. And then we're going to continue to work with them to improve the reliability of the systems way past their target of 9 months to see if we can get to 2 years. But that process allows the customer to validate the system. Usually the engineering team will do verification. So they'll say, I need to build according to the spec. They'll test all the specs. But when you get it to a real world environment, you often discover things that you didn't know. So for example, these systems are going to be in West Texas where it's very hot. We can certainly test for heat. But then there's a lot of sand and dirt and dust flying around, right? There's only so much testing we can do for that. And then there's the combination. Sometimes it might rain and there might be mud and there might be other things that happen to the well and the external environment that you're not aware of. There might be pressures in the gas that you didn't expect. There might be liquid entering the system. And we've done some testing, but maybe it happens a lot more often than what's in the spec. So Pilot allows us to discover all of those corner cases, and also gives the customer confidence that what they're buying is worth putting into their operations. Because most businesses, especially the ones that are in the service sector, are making money through operational efficiency, and they certainly don't want to introduce anything into their operations that's going to cause their operations to get messed up. So this pilot, which is, so back to kind of the big picture of the journey, we start with the idea, we build a prototype, we do some initial testing, and we finally build what we think is a product. We do the verification testing, so we feel like we think it meets the spec. Then we go into pilot, where we do validation. At the same time, we're setting up the production line, and then we get a production unit, and then we do production validation testing, which tests that we can repeatably make the product. And then we have finally the product that can be sold and a business that can be scaled.
Pretty, fantastic, really exciting, neat, cool, however you want to describe it. Start out with an idea and you end up with the strongest robotic arm in the world. And now you're taking that with support to, well, I guess to pilot it, and then from pilot to hopefully mass production.
Yes. Yeah. We all are excited about the impact we can make with our
and that's
products.
just one. That's an easy one that jumps out. It's a little less technical. Pumps running in West Texas and oil and gas. People can understand lifting something up. But talk about patents too. So it's not easy to get patents. Obviously, a lot of smart guys, yourself included, in the company that have developed patents.
Yeah. So before I jump into patents, maybe it might be helpful to take a minute and kind of talk about how the core technology is different than a hydraulic system, right? So the best way to describe it is to actually think about humans and how we move. Anytime we're pushing something, the internals are actually pulling, right? So when you think about all our muscles, the only thing they can do is pull. And it's the muscle in combination with the joint that generates the push force. And because the internal movement is all pulling motions, it's actually very fast. If you think about how quickly you can move your hand for the size of the muscle, move it very, very fast. It's very efficient. When you think about how little food you have to eat to work the whole day. Like they haven't built robots that can operate, humanoid robots that can operate a whole day. And billions of dollars have been spent into battery technology. So you think about how efficient our muscles are, the pulling motion of muscles are. And you think about how durable they are, because they last a lifetime. Yes, they're organic, so they need some blood and nutrients, but generally speaking, they're very strong and they last for a very long time. Now, if I were to take those muscles and replace them with a bladder, so that instead of pulling on the inside, I was pushing. So to open my elbow, I'd pump blood into a bladder that was in the bicep area. And then to close my arm, I would pump blood into the tricep area. You can imagine how slow it would be from all the liquid sloshing around on the inside. And you can imagine how energy efficient it would be because you're moving this heavy liquid that's not really contributing to the output. And then you think about the pressures that would have to happen inside to generate that motion, and you realize that they would fail much faster than muscles. And so that's the core deficiency of hydraulics. They're always going to be slow. They're always going to end up leaking, and they're always going to be inefficient. The inherent design of it doesn't allow you to get any better. And so what the team has done is, inspired by muscles, change the design so on the inside of the cylinders, instead of pushing with liquid, we're pulling with something that resembles fibers. And for fibers, we picked these belts that have been in the elevator industry since, call it, the last 20 years. So they're relatively new. And the elevator industry has replaced steel cables with these flat belts that are made out of steel and plastic. And these belts last the lifetime of the building, and they're very, very strong. And so our core IP is around how we put these belts into a very compact form factor and how we use these belts to pull the piston back and forth, how we take rotary electrical power coming in from a motor, and how we turn it into linear power in a very efficient way. And compared to a hydraulic system, we are 3 times as fast, we're 3 times as efficient, and we're 3 times as durable. And our core IP is around all the bits and pieces of it that takes the rotary power in, converts it into belt power, that packages the belt power into a very small form factor, and then converts the belt power into linear motion on the output.
Is that, just to give an idea, is that one patent? Is that 10 patents?
It's over 20.
Over 20, yeah. So quite a
Yeah.
number of patents. And it's not an
Yes.
easy process to get a patent. It takes a number of years and money and clearly distinct technology.
Yeah, we're really excited. That is definitely one of our moats. You know, a lot of companies that are doing AI these days are struggling with the fact that things that were impossible yesterday, possible today, next month are going to be trivial, and a month from now are going to be free. So, you don't really have a moat in that business. The only thing you can do is run as fast as possible and make sure nobody catches up. So it takes a lot of investment. And the moment you stop investing, someone can catch up. We don't have that challenge. Like, it's going to be very challenging to get into our space. We have a huge moat of patents. There's a ton of R&D. Making atoms move and testing them is very challenging. You can't just do it all in software. And that gives us staying power.
Right. So when you were a kid, did you think you'd be in America? Because we talked ahead of time, so I'm a little bit familiar. Did you think you'd be a CEO of a technology company with robotics? Of course, robotics weren't, I guess there were cartoons and science fiction movies with robotics, but in the US, or how did that journey come about? Your parents must be
Yeah.
proud, I guess.
Yes, they are. I hope they are. I mean, they tell me they are. Although in my household there wasn't a lot of praise, so that that helps to drive you, right? So people talk about Asian parents being sort of very pushy and having very high standards. So when I was in India, I wanted to study computer engineering. I did have this idea that I was going to do something in robotics, but I really wanted to focus on the electronics and the software aspects of it. And at the time, there just weren't enough schools in India that were offering computer engineering as an option. And there was this joint test exam where you could enter into state schools that my family could afford that had, well over 1 million students taking the test, and you had to be in the top 50 if you wanted to do computer engineering because it was a new field and very high in demand. And I didn't make it to the top 50. So I took the SAT. I scored in the top 1%, and that really paved the way for me to get a student visa to come to the United States. And then during that time, my parents had applied for a green card. They'd applied well before I came here for college. I was a 13-year wait for them. And they got their green card while I was still in the United States. And because I was under 21 by a few months, I also ended up getting my green card. And then they immigrated. Yeah, and that was kind of my start. And everything that's happened since then has been a product of hard work, but also the opportunities that the United States provides, being about as close to a meritocracy as you can imagine. System's not perfect, but could have never imagined being a CEO somewhere else. Wouldn't necessarily have all the paths. And in the United States, if you work hard and you deliver, it doesn't really matter who you are, and you just keep getting responsibility. People want to work with people who are willing to solve problems and don't give up.
I like the Walmart example. You can start out without any education, the simplest job, and you can be a store manager, which those stores are very large and highly paid. They just care about your abilities and your work and your accomplishments when you're there. So yeah, a lot of good things in America. Glad you're here. I've been here a long time now, and it's also hard. A lot of those companies, or at least one or two, I recall one specifically, didn't get funding. So this company you've been there 2 years. Presumably they brought you in to help take them to the next level, but they've been around since 2011. And so those rounds of funding that, didn't come through from the other ones. However, they made it to where there's some stature and stability, and based on the patents and technology, and you and the team and them a future, because that's not easy too. All these people with ideas and technology that are really smart, and I mean, they don't usually make it 15 years.
That's right. That's right. Yeah. So we've, as I mentioned, the company when I joined was working on DoD contracts and joint development contracts for proof of concepts and so on. And now it's taken me roughly 2 years. I'm doing what the founders wanted to do when they brought me on board, which is getting the company to a more commercial setup. And as part of that, we've had to raise money. One of the things that we're doing that's innovative is how we're raising money. So what we did was we took advantage of this law called regulation crowdfunding, which was passed by the Obama administration. I think it's going to get expanded by the Trump administration. And they allowed companies to allow retail investors, everyday people like you and me that aren't necessarily accredited investors, to invest in private companies. And they put some restrictions in place to make sure that it was all fair and above board. And the whole process is that a company like ours can partner with what is called a platform, and the platform vets the company, and they make sure that all the right disclosures are provided to retail investors, and then they marry the two, right? And so we picked WeFunder as our platform, and we took our last institutional round, and we basically opened it up to retail investors, and using this rule called regulation crowdfunding. And last year, we ended up getting $5.8 million of interest from retail investors in the company. We're only allowed to take 5 million in 12 months. So our round was oversubscribed. We ended up being the #1 campaign under the regulation crowdfunding laws last year. We just opened up a second round, but we've already raised 2 million. And so we're doing well. Our story is resonating with a lot of folks, and we're getting many people that have been in the hydraulic space, that have used hydraulics in some way, that understand the challenges of it and see that the transition away from hydraulics is inevitable, right? And so we happen to be positioned very well to take advantage of that transition.
One, you could be in a science fiction movie too. You've got the claw. So don't leave out the claw.
That's right.
A little attempt at light humor for a serious topic of a lot of important things that can change the world. Yeah, robotics is just one, I guess. I mean, AI is a big part. Robotics is and AI are Elon Musk is obviously putting them together. So I think it's going to be constantly. Of course, AI is going to be in everything, but if it isn't already. There's a movie, iRobot too. I don't know if it had anything to do with the company, but probably the first exposure a lot of people had to robots was that movie.
Yes. Humanoid robots in the way we think of them, right? And so
Yeah,
just like mimicking humans and so on and so forth. Definitely
those
that
type of
movie.
robots. Yeah, I should be more specific, right? Human robots.
That's
Yeah.
right. Star Wars had some robots that got people inspired. So the common connection between the two is the founders of iRobot were inspired by the book iRobot. And so they built a company and they named it iRobot. But one of the fun things that happened is that when the iRobot, the movie came out, they had a few folks from the company be in the movie as extras, which is really interesting. And then when the premiere of the movie happened in Boston, everyone in the company got free tickets to go see the movie. So it was a fun event, a good team building event for us.
Oh, yeah. Well, I don't know if there's anything you'd like to wrap up on, Tim, but I think that's fantastic. A lot of people are I think everybody should watch this and learn and enjoy. So congratulations and best of luck. And feel free to wrap up with something if you'd like to, or we can call it right now.
Yeah, so if any of your viewers know folks that are in the hydraulic space that are having trouble with their hydraulic systems, we'd love for them to reach out to us. Our website is riserobotics.com. And then if any of your viewers feel like this is a technology that they want to own, be part owner in the company, they can reach out to us at invest.riserobotics.com. But if they just want to connect with me, they can find me on LinkedIn, and I usually accept meeting invites from interesting people.
Fantastic. I love the name too, Rise Robotics. Whoever came up with that was a smart guy.
It's not me, the founding team did. Yeah.
I know, but hey, you want to be around smart people, and they got you. So, well, hey, terrific. Thanks again, and we'll be in touch.
Thank you, Henry. Thank you so much.
Thanks for tuning in. Remember to subscribe and hit the notification bell so you never miss another episode. You can also search Henry Harrison Podcast on your favorite podcast platforms.